Okay, hello everyone. Welcome to the lecture 5 of the series Introduction to Labview. Today we were going to see the hands-on on the real-time myDAQ data acquisition systems. So for that, I have myDAQ with me. If you people have any data acquisition device from National Instrument like USB 600 X series or CDAQ or myDAQ or any kind of data acquisition device, if you have, you can relate this video with you. And in this video, we also see the importance of NI MAX, which is a additional software that we can have with the Labview. It is a very important software when we are integrating the real-time hardware with the Labview. Okay, so first we will start with the introduction of NI MAX. So whenever you install a Labview, the NI MAX software has already been installed with the Labview itself. Now, NI MAX stands for National Instrument Measurement and Automation Explorer. Here you can, if you have connected any real-time hardware with you, you can basically the NI hardware. You can see here in on the NI MAX the integration, the whatever the test panel, you can test the hardware on the NI MAX also. Also, when you are dealing with the Rio devices, then to install the software or to add on the any additional software in a Rio, you can also do that using NI MAX. So let's start with the NI MAX. So this is the NI MAX window you have. Now I have connected my DAQ with my computer. So this is where you can see in the devices interfaces. These all are the hardware that I have connected with my system. So these are the hardware that I have simulated virtually in my laptop. And you can also simulate these hardware, but for now I just remove that so that you can have a proper description with you that how these can be simulated. You can simulate the data acquisition devices virtually in your Labview also using the NI MAX. For that, it is very simple. You can just go to the devices interface, right click on the devices interface and excuse me, click create new. There you have seen that this kind of window has been emerged, and you see this simulated NI DAQmx devices or modular instrument. You just click on it and there's a window open in which they will ask that which kind of chassis or hardware you want to simulate virtually. Now these can be done only for the data acquisition instrument, not the Rio controller based instrument, for example Rios. So I'll just write it that I want to make NI myDAQ. So this is my NI myDAQ, and I just click OK, and my DAQ has been simulated virtually. You see, this is my simulated DAQ. Now, this is the real DAQ that I have connected with my computer. The difference is the wiring. You see, my virtual DAQ has been in an orange color or yellow color, and my real-time DAQ is a black color. Now, you can test. NI MAX is a very important software when you want to test your sensors or any device without using a Labview. Suppose you don't want to go on a Labview, you just want to test any devices, or you want to test any sensor whether they are giving you a data or not. So you can go directly from here also. There is a test panel available. Here you can just click on the test panel, and you see this window has been opened, and these are the channel that has been already present in a myDAQ, and you can have like analog input, analog output. Since you want to just test it, so you better see the analog input. And on channel 0, there are two channels for analog input, channel 0 and channel 1 in myDAQ, and you can just have the maximum and minimum input, like so I can have like 0 to 10 Now this is my real-time DAQ, and I have connected the potentiometer with me. So I'll just start it, and you see there is a value has been came, like they are this is very different value, and I'll just changes the value of potentiometer, and the value is changes. So this is my this is a real-time DAQ, and if you want to see the changes, or you want to see that how it is has been changed, you can just stop here right now, and you see the for the let's see in a virtually simulated hardware how this test panel has been seen. We just click on it, and whenever you start, because it is virtually generated, so you see it will go up to 10, and then I should have give the value to, I think, 5 to 0. So it will go that value soon. So I will start it, and then it will reach up to the maximum input limit, and then it will reduces to the minimum input limit. So this is something like sinusoidal wave, and it is virtually simulated like kind of signal, not real-time signal. So this is how the virtual DAQ, you can see, you cannot see this kind of behavior in a real-time DAQ. Okay, so I'll just stop it. So this is just the introductory part of the NI MAX. Now I'll just I have to remember the my DAQ name. So my DAQ is DAQ1, the real-time DAQ. Now I have a very small circuit with me, in which I have connected a potentiometer. That is a 10K potentiometer. I have connected 10K potentiometer with a 5-volt power supply, and with varying resistance, I'll just see that whether I have connected 2 LEDs, and depending upon the range of my potentiometer goes from 0 to 5 volt, I want to see that which of my LEDs has been glow. So it is like a alarming system, that kind of thing. So for that, let's come to the Labview. In Labview, where you can see the DAQmx module, you have to go to the function palette. Then there is a function called measurement input output. You just go there, and there is a NI DAQmx module is available. Now this is a NI DAQmx module. You see, this is a low level VI. We have 2 kinds of functions available with us when we are going in an advanced Labview. The one is the low level VIs or low level function, and one is the express VI, which is a high level function, or you can say that they are the whole bunch. Like, you don't need to, you just give the input and you can get an output. You don't need to start the programming from the scratch. But when you are, but if you work very if you have a very if you have very customized work with your task, then you have to go by the low level BI, because you then you have to go by you have to build a program from scratch. So you need to create a channel, you need to create a task first, then you need to create a channel, then you can start the program, then you can read or write the program, and then you can have stop the program. So this is something, a path that you have to create when you are dealing with the low level VI. We will see in our session here that how the low level VI is different from the high level VI. Now, whenever you are working on a hardware, the first thing you should do, you have to take a while loop. Why? Because we cannot just stop the hardware using a abort execution. This is not a stop terminal, this is a abort execution, and we cannot abort a hardware system just like that, because it will damage the system due to current sinking problem. I already told you, I think. So this is I have to use a while loop, and now I'll take a DAQ assistant. For this is a express kind of VI. Here, whenever I just click it, it will ask me, first it initialized, then it will ask me whether I want to acquire a signal or whether I want to generate a signal. So if I'm if I'm taking a data from a sensor, then obviously I'm acquiring a data. and whenever I'm giving to a value to some actuator or some output devices like LED, then I'm generating a data. Now here I'm just acquiring a data. Now it will ask that whether you are acquiring analog data, digital data, or counter input data. So I'm actually taking a voltage analog input, and then it will ask that which kind of parameter you have. I'm having a voltage parameter with me. So I'll take the voltage. Now my DAQ is my DAQ 1. So I've connected my my potentiometer with the channel 0. So AI 0, and I'll just finish the task. When I click the finish, then what the Labview has done, it has already generated the task and the channel and everything with the whatever required for acquiring a data. So here I have to give the parameters that I have only from 0 to 5 volt. Now if I run here, I can see I got some value, but it is in a negative terms. It doesn't matter. Okay, so I'm having a value something like -5 to -1 to -5. So it is changing from -1 to something, because it is a potentiometer, it is a sensor, there is some internal structure is there. We will not discuss here now, but my channel has been created. Now I have to stop. So you see here also I can just check my if my sensor is getting a data or not. So I'll just click OK, and my task has been created now. You see, it is saying that I am building a VI. Actually, it is just building using a low level VI. It is building a path and created a task. Now, the second thing is whatever the value you are getting here, it is in the form of what we can say, it is in a form of dynamic data. Whenever we are dealing with the data acquisition devices, first we have to convert the dynamic data into a static data. All the real-time data are the dynamic data, and all that simulated data is a static data. So now I have to deal in a Labview. So it is a virtual environment. So I need to convert the dynamic data into a static data. For this I need a conversion. So I just start a quick draw, and I need from dynamic. I don't know, from dynamic. Oof. So now it will ask me that what kind of data I have. I have a single scalar data with me, and it is a floating point data type. So I have a scalar data with me. Now I need to, because I'm getting a negative value, I need to negate my value, whatever the value I'm getting, and finally I got a value. I'm getting a data here. You can create an indicator, and this is the data. Okay, and you can replace it with the okay. So this is my data, and now I need, if I run it, because it is a while loop, I need some timing because it executes very fast. So I'll just give the 200 milliseconds so that I can see whatever the data I have. I'll just run it, and you see I can get a value. Why it is giving negative? Okay, I'm getting a good value, I think. -6. So I have to remove that negate button now. Oh, I think it is not placed there. Yeah. So this is my value. Now I need to create a alarming system. So for example, if my value have been crosses using a comparator, if my value has been crosses some certain value, suppose if my value has been crosses 4 signal, so it is something alarming situation. So my LED has been glow. So which kind of LED I am having? I need this LED. Suppose it is a alarming situation. So I'll just take a property and it can get into a like in a red zone. Okay. So this is something alarming situation. I'll just write it. Alarming situation. Okay, so I think the size has been current font. The size is very low, so let's just okay. So it is very, just keep it normal. So this is my alarm. Justify as center. Now this is my data, whatever the data I have. This is my stop signal, and now I need a normal condition LED also. So what I can do, whenever it is not above this thing, then I can have one normal situation LED also. So for that I need normal. This is normal condition. Okay, so I will change the color to properties to gray. Okay. So this is my data, this is my alarms, and this is my stop button. Okay, stop button should be in a like. Okay. Now this is something that has been virtually created, but I need what you can say that is a something like a voltage monitoring system. Voltage monitoring system. Okay, so just size 24, style is bold, so I'll just drop it. Now I want in a real hardware also, whatever the alarm system I have been created, I need in a real hardware. So for that I need to get a DAQ assistant again. Now this time what I have to do, I need to generate a data. I need to generate a signal, okay, using a Labview. So I'll go for the generating a signal, go to the digital output. Now in digital signals, you have two options like line output and line and port. Now using line, if you want to access a single, we have 8 channels, 8 digital channels in data acquisition device in myDAQ, not data acquisition device, in myDAQ. Otherwise, if you are using CDAQ, there are whole another specialized data card is available for the digital input outputs. Now, in myDAQ, we have 8 pins, 8 channels that are exclusively for the digital data. So, if you want to access each channel separately, you can go for a line output. Or if you want a whole port, like whole 8 channel together, then you can go for a port system. So I want a single channel access, so I'm going for line, and I have connected my LEDs with line 0 and line 1. You have to be very attentive here, because some people have selected all the channel, and then they get an error in the end. So you can also check your LED. Sometimes what happen, it is a DAQ problem, not a problem, it is something that internal structure it is having. Sometimes what happen, whenever you click, whenever you give the 0 signal, then the LED glow, and whenever you give the 1 signal, then the LED will off. So it is like inverting line. So for that, in that case, we have to click that button, but I'm not having that scenario right now, so I'm okay with this. If I glow this, if I give 1 to these channels, my LEDs are glowing. If I remove it, my LEDs stop glowing. So my LEDs, my channels are working fine. So I'll just stop this here, and okay, now my task and my channel has been created. You can change the name also here, the DAQ assistant name, like voltage measurement, and you can have here the alarm systems. Okay, so now I have 2 channels. You see, I have taken 2 channels, and I need to take a 2 inputs to give to that channels. So for that, I need to go to the build array function, because I have 2 data with me. So using a build array, each channel get 1 data depending upon the array data. So on top, I get I'm connecting with the first LED, and in next I've connected the second channel data, and this is the data. You should be very much careful whatever you are doing here. So I'll just short it little bit, and yeah, now it is fine. And I connect the data directly. Okay, so here I have connected my channel. Now whenever I run this data, and depending upon the value, my LEDs has been glowing. So it is a very good signal I am having. So whenever my channel, whenever my data is above 4, then my LEDs, red LED will glow, and whenever I decrease my number to 3, my normal green LED will glow. So this is how it has been. I have done using my potentiometer. So my data has been from 3.7 to 8.3. You can see this is my monitoring system, and it works very beautifully. Okay, so it is not glowing. Okay, you see when the green LED glow, it is like that. So it is not glowing. So this is how you can work very efficiently using a data acquisition device. And so this is a high level VI. Okay, so I'll just stop here. And if you want to go by the low level VI, it is a very simple. You just go, and I have to access. If you see, if you just click on it, and you want to see the value, whatever the value we are having, so you can just see that inside it. If you want to see, you can just click it. Yeah, sorry, I think there's some you can get a code here. Okay, not here. Yeah, open front panel convert. Yeah, this is the code you see. This is the overall code. You see, these are the low level VIs inside the high level VI. So we can go do that also using a low level VI. It is a very simple task, nothing to worry about. Okay, so for a high level, for a low level VI, what you can do, you can just you need DAQmx, and you need I think I have already created a task. You need to create a task first from here. So I have so many tasks created. I don't remember any of it, but I have created so many tasks here. So I just remove that task. Maybe I should remove one by one. Okay, or you just need to create a new task here from here. Okay, so for example, I already access that task, or I can start from here also. In advance, I have created a task. Then I need to start a channel. Okay, you need to start, you need to read, and you need to stop. Okay, these are the things I can have. And I need a task constant here, and you can just collect these all the tasks that I have created in previously. And so I need to start a device, start a channel, and this is how you just connect these things, and eventually you can get a value. Just collect it, and yeah. But here I need only a read function inside a while loop, nothing else. So create a control here, and then I have a timer here. It's 200 millivolts, and just take a data here, create a indicator here. Okay, so I just need to show you just what a low level VI have done. So if you want, you can see the label also. Okay, I need to create a task here. So for that, go browse. If I don't have a task, create a new task. To NI MAX. I need to acquire a channel signal voltage using myDAQ 1, channel 0. Next, so my voltage task is 2, or you can just the voltage measurement. Okay, finish. So this is my task has been created now. Same principle, whatever I have. So it is like stop from 0 to 10. Okay, I'm creating a task. Okay, so now my task has been created. I have selected my task, and I'll just run my signal here. I think everything is fine, and I've run. You see my value has been come here. Okay, wait, so this is how you can have a value here. Okay, I need to define here also single channel, single sample, DBL format. Okay, so yeah, I run it. My value has been changes. I don't know, it's coming out 7.9, and if I change it, it will change in the value. So this is like a low level VI. I think we have covered today every possible way. If you want to go, if you see that high level VI, the express VI is easy to use using our DAQ assistant, then go for it. And there are some points when you need a low level VI, obviously. So depending upon the application. So thank you for today, and we will see in the next series whenever we made to the advanced topics on this. So thank you so much.